So the next thing that we're going to go over is natural logs. Last section we learned about the special number e, which is just a exponent with a special base. The inverse of that is what's called natural log of x, which is a shorthand of saying log base e to the x. So yeah, these two go together and they cancel each other out when they're right next to each other. All your traditional log rules apply to natural log as well. So if I have two that are added, I multiply their parts. If I have two that are subtracted, then I would divide their parts. If I have a power, I can bring that down to the front. So all the log rules apply. So let's look at this example 12. It says find the exact value of, and then it gives us ones where the natural log and e are right next to each other. And like I said, those are inverses of each other. And the effect is that they cancel each other out. So you're just left with the value that's following e, which is 2. Same thing here. E and natural log are inverses of each other, so we're left with 5 for B. And then for the natural log of e to the x divided by e to the y, we want to go ahead and use some log rules to simplify those powers first before canceling out anything. So natural log, since they're dividing, our rule says that we would subtract those powers. Remember, if it's, let's write the rule over here. We have a to the m over a to the n, and you would subtract those two with the exponent rules. Oops, I lost my piece. Hold on, let me get it back. There it is. Okay, so I'm going to go ahead and subtract the y from the x. So it would be e to the x minus y. And then those two cancel each other out. So you're just left with x minus y for part C. Okay. The next thing I want to do is show you how to quickly solve a logarithm using an exponential. So let's see. So if I have something like this, natural log of x equals 4.1. In order to get to the x that's on the natural log, I would go ahead and take e to both sides, and those push both sides up to a power. That's why I wrote it kind of big. So that would cancel out the e and the natural log, and you're just left with x equals e to the 4.1, which is just a number. It's just a number there. So let's figure out what that is. Let's see. E to the 4.1. Oops. $60.34. And then you're done. The converse of that is if you're given a exponential with base e, then you would use natural log. So let's take a look at one of the simpler ones of those. So if I have, I don't know, e to the 2x equals 7, this is a made up problem. In order to bring this power down, just like with a regular log, I'm going to take natural log to both sides, and because my log rules still apply on natural logs, the 2x can jump to the front. Oops. Okay, and then those cancel. You'll be able to divide by 2, and then you will have what x equals if you take natural log of 7 divided by 2.